Imagine looking at the surface of an alien planet that is so hot and deadly that a human being will be crushed instantly. In fact, this place has such extreme conditions that no probe can survive there for more than a few minutes to hours. And yet there are photos of it, no simulations, no computer graphics, but real images that impressively show us the bizarre creations of the cosmos in our planetary neighborhood. Today we'll take a closer look at the first and so far only images of the surface of Venus. We'll see how Soviet engineers on the Venera mission managed to develop probes that could withstand the hellish conditions of our poisonous planetary sister, and what exciting impressions they captured with their cameras. Stay tuned until the end, because we'll show you why these photos are absolutely unique, not only from an astronomical point of view, but also from a historical perspective. If you had asked a researcher in the 1950s what Venus actually looked like, the answer might have been something like this. Our neighboring planet resembles the Earth in its prime. It's true that the entire celestial body is enveloped in an impenetrable veil of clouds, but beneath it lie dense primeval forests and vast oceans that may well have given rise to one or two living creatures. And even from today's perspective, it cannot be denied that Venus and Earth are strikingly similar in some respects. While celestial bodies are comparable in size and mass, Venus also consists of an iron-rich core, a rocky mantle, and a thin crust. However, that is where the planetary similarities end. Unlike the scientists of the past, we now know that Venus is by no means a prime example of a life-friendly world, but rather a place that could not be more extreme. Its atmosphere consists of over 96% carbon dioxide supplemented by nitrogen and traces of sulfuric acid. The pressure at its surface is a whopping 92 bar, which is 90 times the pressure of Earth's atmosphere, or the pressure at a depth of 900 and below sea level. But even the average temperatures there are scorching hot in true Venus style at 465 degrees Celsius, and just so we're clear, that's hot enough to melt lead. This heat is in turn due to the extreme greenhouse effect. When sunlight penetrates the atmosphere and is absorbed by the ground, the heat radiation cannot escape. As a result, Venus is even hotter than Mercury, even though the latter is naturally closer to the Sun as the innermost planet. And as if all this weren't enough, sulfuric acid rain, violent storms, so-called superrotations of the atmosphere, and a permanent cloud cover of sulfur dioxide are also part of everyday life on Venus. The latter also makes it impossible to observe the planet's surface from Earth, and led earlier generations of experts to come up with some exciting speculations that ultimately proved to be untrue. The push for Venus, the first real images of our neighboring planet. Given the planetary situation, it's hardly surprising that Venus was long considered unreachable. And yet in the 1960s and 70s, the Soviet Union decided to reach out to our neighboring planet and launched the Venera program, one of the most ambitious projects in the history of space travel. Venera simply means Venus in Russian. The mission's goal was to collect insightful new data and, if possible, provide images of the surface. But how do you send a probe to a planet with a pressure of over 90 bar and a temperature of 465 degrees Celsius? Well, at first you couldn't, because the Venera program didn't get off to a good start. Venera 1 was lost shortly after its launch in February 1961, and Venera 4 burned up in the atmosphere of Venus. Other probes exploded, were destroyed, or lost contact. But the Soviet engineers didn't let these setbacks get them down. With each new mission, they learned from the mistakes of past. The technology became more robust, the heat shields better, and data transmission more stable. In 1975, the moment finally arrived. Venera 9 landed on Venus on October 22, 1975, and survived for 53 minutes before succumbing to the harsh conditions. And yet this brief hour was enough to give humanity its first direct view of the surface of Venus. And although the image may not be of the quality we expect in our 4K age, we must not forget that this low-resolution black and white photograph marked an absolutely historic moment. After all, it was not only the first image of the surface of Venus, it was also the first image of the surface of another planet ever taken. Here we see a rugged, flat terrain littered with boulders. Just 3 days later, however, the Venus photo album was expanded with another image, Venera 10 made close contact with our neighboring planet on October 25, 1975, and once again captured its natural face with its camera. The photo shows us a different terrain which appears just as rocky but has different geological features. More precisely, the rocks appear much flatter, almost stacked on top of each other. And what may objectively be just a few chunks of rock was also an outstanding triumph for space travel. For the first time in history, we were able to marvel at the surface of another planet from the perspective of a probe on the surface. The first color photos of Venus. And yet the photographic achievements of Venera 9 and 10 were only the beginning, because the real masterpiece of the mission came just under 7 years later. Venera 13 and 14 were significantly more robust than all their predecessor probes. Their housings were thickly armored and the cameras were equipped with special protective mechanisms to withstand the extreme heat. After Venera 13 landed on Venus on March 1st, 1982, it survived for a full 127 minutes and transmitted something truly fascinating. The first photo showing us the surface of the planet in color. More precisely, we see a flat, shattered landscape of rock beneath an orange sky caused by the dense atmosphere that strongly filters the incoming sunlight. A few days later, on March 3rd, 1982, Venera 14 followed. The lander survived 57 minutes on the surface at an outside temperature of 465 degrees Celsius and an atmospheric pressure of 94 bar and once again presented Venus in all its colorful splendor. Compared to the images taken by Venera 13, the pictures are almost identical, but we could actually have revealed the colorful face of our poisonous stepsister a little earlier. In fact, Venera 13 and 14 weren't the first probes to bring more color to Venus, but since the camera covers of Venera 11 and 12 didn't come off, they could only transmit data and no photos. However, in addition to color photos, Venera 13 and 14 were also able to transmit sound recordings. These were acoustic measurement data which were later interpreted and converted into audible sound formats, presenting us with the low-frequency vibrations of the Venus wind. And in fact, these are still the only sound recordings from another planet with a solid surface. The technology behind the photos. But how was it actually possible to take photos under such extreme conditions back then? Well, the cameras on the Venera probes were actually located in swiveling towers and protected by special lenses. Their lenses were automatically exposed after the probes landed. In addition, the images were captured line by line, similar to a scanner, and then transmitted to Earth by radio, and with Venera 13, a complete image scan took up to 13 minutes. The probes also had two camera units, one for the left and one for the right angle, which combined to create panoramic photos. The images were then color-corrected since the atmosphere of Venus scatters light strongly. The raw images often appear greenish or brownish. Scientists therefore reconstructed the probable color rendering under Venerian conditions. Ultimately, however, we should not forget that it's almost a miracle that the technology survived so long back then. After all, despite active cooling inside the probes, temperatures inside them exceeded 200 degrees Celsius. At the same time, we have also proven that it's possible and that we can send probes to Venus that can successfully take photos there. But then why aren't there many more photos of Venus? Well, that's easy to explain. The conditions there are simply murderous. No Western probe has ever taken a real photo of the surface. It's true that NASA missions such as Magellan provided images of our neighboring planet, but these were obtained by radar scans from orbit and not by photographs in the true sense of the word. Added to this is the fact that after the end of the Venera missions in 1985, no space agency seriously attempted to return to Venus. The European mission Venus Express mapped its atmosphere but did not land. But what does the future hold? Well, the good news is that the wait could be over in the foreseeable future. NASA is actually planning to finally send another probe to Venus in the 2030s as part of the DAVINCI mission. The descent probe will take high-resolution images during the landing phase and transmit them back to Earth, giving us the first photos of the surface of Venus since the Soviet Venera 14 mission in 1982. And you can now treat yourself to a free subscription. Simply click the thumbs up and then subscribe to never miss a new video from us again. We'll see you soon.